Hey Thinksters, and welcome to this tutorial about Python matching groups. So in particularly we are looking into the Python package re, which has a lot of features. It's a very powerful Python package for regular expression processing. So we are going to talk about matching groups in Python, but oftentimes you will also read the term capture groups. So I just use this to write now. So we have capture groups is also a common term for the same concept. So if you have read capture group somewhere, then it's the same. And after this tutorial, you will know why they are also called capture groups. So first of all, on a conceptual note, what is a matching group? So for example, if you use in the parentheses to structure mathematical expressions, so yeah, we have something like this versus say 2 plus 2 times 2. Okay, so here we have two different ways of expressing the same mathematical expression. Here in the first case, we first compute 2 plus 2, which is 4. Then we multiply it with 2, which is 8. Here in the second expression, we have 2 times 2, which is 4, and we add 2, which is 6. So we have different meaning with by using the parenthesis in a different way. And just as you do it in a mathematical expression, we also do it for regular expressions. Okay, so we use parentheses first and foremost to structure regular expression. So for example, an example regular expression would be this one. So we have the character A, we first match the character A, then we open the group with the parenthesis, we have the OR operator, so we have B or C, and then we close the regex. Okay, so this regular expression would first match the character A, and then it would match the regular expression in this capture group or matching group. And the matching group is an OR operation, so we will either match B or C in the matching group. Okay, so in the whole content enclosed in the opening and closing parenthesis, this whole thing here is called the matching group or the capture group. And we can have multiple matching groups in a single regular expression. So for example, we can also have another regular expression which looks like this. So we have one group, one opening parenthesis or opening bracket. Then we have another one, CD, and so on. Okay, so it's possible to use as many as you would like. You can even so hierarchically structure them and nest them as you like. So in one big advantage of matching group is of course to allow you to structure your regular expression. But another big advantage is that it captures the matched substring. Okay, so and it captures it so that you can retrieve it in other parts of your regular expression, and or even after the analyzation. So after we have matched the whole regular expressions, you can use it to get the result, to get the captured substring, basically. And you will see an example in a moment. So say we create the regular expression B. So match B either 0 or 1 time with the question mark operation. Then we opening the capture group. We have two characters, character A and an arbitrary character indicated by the dot regular expression, and we have an arbitrary number of those. Okay, so this is indicated by the asterisk operator. And so this is our regular expression which we have. And now we can test different strings. So we use the find_all function, which uses a pattern. The pattern we have already found, which is our regular expression 3. And say now we have different strings like B, A, C, A, C, A, C, A, C, A. So for example, this is one, and you can see that it matches the pattern. Okay, so this whole regular expression matches our string. Why? Because we have character B followed by an arbitrary number of characters, AC, 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 and so on. Okay, so this is so they would match the regex, but then we also have like different other regular expressions that would match it, like A, those will be matched by our pattern, and we can even have even I would say that the empty string is would also match this pattern, for example. Okay, but this is just giving a few examples. So the use of the parenthesis for structuring the regular expression is intuitive, and it should come naturally to you because it uses the same rules as are well known by you, as you already know from arithmetic operations. So, but there's a more advanced use of the regular expression groups, which is the retrieval. So you can retrieve the matched content of each matching group. So the next question naturally arises, how to get the first matching group. So if you have matched something, you have used the matching group, for example here, how can we get the contents of the first matching group? And there are two basic scenarios where you want to do this. The first is you want to access the matching group in your regular expression pattern itself, to reuse partially matched text from one group or somewhere else. And the second case is that you access the matching group after you match the whole regular expression to analyze the matched text in your Python code. And we will now investigate both cases, so how both cases work, and we start with the first case. Okay, so say we use the search method now. The search method, so I just use raw strings. This is this R string with an R prefix means raw string, so that I can use escape characters in my string. Okay, now we open the group. We have a character J, we have an arbitrary character indicated by the dot, regex, and then we have the character N. So we have 3 characters starting with J and ending in N. Then we have an empty space. The word is and \1. So what does \1 mean? Basically, \1 will just at runtime the regular expression will be matched from left to right. So first it will match this part of the regular expression. It will match a word that matches this whole group, and this word can be, for example, John or something. Yeah? So John could match this part, this group. But then it will be captured in. So in this group will be captured. So because it's a capturing group, yeah. So the group operator, the parenthesis itself, is not only there for structuring the regular expression, it's also there for capturing in the already matched regular expressions. So at this point, it has matched the text with the string John, and this is stored in the first capturing group because it's your first group which you have created within this regular expression. And therefore, you can later access this content which you have matched by \1 in the same regular expression. Okay, so this allows us to search for patterns where you have some reoccurring subsequences in your regular expression and you want to check them. Okay, so for example, and this can be like John is John. So now we have a string. We apply it to this string and we try to find this pattern in this string. And this pattern basically, it will first match John. It will keep matching the empty space, the I character, the S character, the empty space, and then it will match the contents of the first matching group, which was John. So it should match the whole string, John is John. And actually it does it, okay? And now just for showing you that this is really different than doing this one. So now we have, it seems that that this is doing the same because it's the same regular expression as we had initially here, John is John. But now actually, John is Jan. This would also match our whole string. And previously, this was not the case. I mean, John. So if you take the original one, and we have another string like John is Jan, then this would not match the regular expression because here we use the contents of the first capturing group, which is at this point John. even Jan is a valid, so it is a valid match for the first capturing group, but we are not looking for another capturing group. We are looking for the contents of the first capturing group, which at this point is John. Okay, so in this, therefore, it's a really powerful concept. You can reuse partially matched substrings later in the same string. But then there's a second case. So sometimes you don't want to use it, like the contents of the capturing group, you don't want to use it in the same regular expression. You just want to check after you have matched the whole regular expression, you want to check what is in the first group. So which part matched the first group, basically. And to do this, you can basically, so now we run the same thing here. Say we run this regular expression and say we store it in our match. So now we have a match object M. So this match object, which was previously printed to the shell, is now stored in our object M. And now we can use the method m.group. And the method just takes one parameter, one argument, so it should indicate the groups which we want to have matched. And so if you use group 0, then it will match the whole regular expression, the whole matching. This will give us the whole match, basically, the whole sentence matched. But if we use so if you increase the group count, basically, then we get the first matching group. And now we can also try to get the second matching group, but the problem is, as we didn't have another opening parenthesis, we don't have a second matching group, so therefore it's not possible to use it. Okay, but you just should know that the first matching group can be accessed by m.group1. So just use the matching object to access the contents of the group later in your Python code. So not within the same regular expression, but later in the Python code. So this is like the whole power of groups. It allows you to reuse and retrieve the contents that were captured, that were matched and consumed by the regular expression engine. And then, of course, the question is, so, I mean, if you have multiple matching groups, how do you do this? Basically, now, if you understood everything until now, it's simple. So we, again, use a raw string and say we have multiple groups like j dot dot and empty space j dot dot. So we have 2 times 2 groups here. They look similar, but still they are different groups. Then we have an arbitrary number of white spaces followed by the second capturing group. Okay, and now we can have like for example, a number of names here. And now what will it do? So you can just think about this for a moment. Yeah, I mean, this will match the first part, John. This will match the second part, Jim. Then we have some white spaces, and then we want to match Jim again. So we want to match the contents of the second matching group, which was this one. And this has matched Jim initially. So, and now we want to match Jim again. So this should match the whole string, and it does. Okay, so and then of course if you slightly modify this, if you have John, Jim, John, for example, again, then this doesn't match anymore, yeah, because it requires to match the second. So you see that there's no matching object, there's no output. Yeah, so the contents of the second group is Jim at this point, because Jim, this word matches our second group, and therefore yeah, it requires Jim and not John to come here in the text. So therefore it doesn't find any match. Okay, so this is basically how you can use it in the same regular expression. You can just use the number counter. So to match the second group, you have \2. To match the third group, \3, and so on. You can do this until \99, I guess, and then it's done. So you cannot match like more than 100 or more than 99 matching groups, or retrieve more than 99 matching groups at least. Okay, and then of course you can also like later you can store this whole thing again in the matching object. And then you can access like the whole, result. You can access only the first matching group. You can access the contents of the second matching group as well. Okay, so this is very easy. Now, but accessing, now we come to a different topics, which is named groups. So accessing the captured group using this number notation, which I have just shown you, is not always convenient and sometimes not even possible. So for example, if you have more than 99 groups in your regular expression. So, and the major disadvantage of regular expressions is that they tend to be hard to read. And it's therefore important to know about the different tweaks to improve readability. And one such optimization is a named group. And what is it, a named group? It's really just that. It's a matching group that captures part of the match, but with one twist, it has a name. And now you can use this name to access the captured group at a later point in your regular expression pattern. And this can significantly improve readability of your regular expression. So let's have an example. Say we have the following pattern. So our pattern is stored in a string, and now we have like one named group. I will replace it later with the correct syntax. Then we have an arbitrary number of characters, so characters except the new line character, and then we have the same named group that closes. Okay, so we want to find all characters that are enclosed in the same two types of characters. And what characters we want to have is quotes here. Yeah, so we want to find all strings, basically all strings that are, so all like substrings that are enclosed in quotes. And these quotes should be of the same type. Okay, and how do we do this? Yeah, basically now we can use the named group, and you start the named group with the question mark P syntax. So this is like constant, the syntax is always the same. Then you have in the diamond operator, so you have a diamond operator, and within the diamond you just type in the name of the group you want to have, like quote. Okay, so this is our syntax for a named group, and this starts a named group. And now we can put anything we would like to do in the named group, like selecting our quote that we want to match. And later we have again the same syntax, like question mark P, to retrieve the contents of our named group. So now we have to give the name of the group which we want to access, and the name of the group was quote. Okay, so therefore we just type quote, and this is already done. Okay, so this thing is basically the retrieved group. It just gives us, at runtime it will insert the match which was generated by this part in the text, and it will, so if this, for example, if this would match like a single quote or so, then this would be a single quote as well, because it's just the same string. So therefore we can, like, dynamically we can find all texts that have that are enclosed in the same type of quotes. Okay, now everything that is missing is to have basically like a character class or something where we put all types of quotes which we want to match. So here we have the double quote and the single quote, for example, and we have to escape the single quote, otherwise we would just just close our string here. Okay, so this is our pattern, and now we also have a text. So for example, this text, she said hi. Okay, very simple text, and you see this is the thing which we want to search in this text. So this string hi is enclosed in double quotes, so it should match our pattern. Okay, let's check. Let's print re.search pattern text, and you can see, okay, we correctly matched our substring quote, double quote, hi, double quote. Okay, so therefore it would not match. So say if you have another text, like if we had she said hi, and then we have another quote, like I need to escape it now, another single quote. So we have two different types. This is one quote character, and this is one quote character. Now we have two different quotes, and this, I mean, both independently would basically match our named group, but we are searching for the exact same quotes here, yeah? So we just take here the contents of the first name group and we want to match exactly them. So the contents of the first name group will be the double quote. And here we have the single quote that closes our expression. So therefore, this doesn't produce any match. Okay, so I hope you got this. Now, one question maybe, so in the previous examples you have seen how to match and capture groups with the parentheses, like opening parentheses and closing parentheses. And you have learned that each match of this basic group operator is captured, so that you can retrieve it later in the regular expression with the special commands \1, \2, \99 and so on, or even after the match with the method m.group1, 2 and so on. But what if you don't need that? So what if you just need to keep your regular expression pattern in order, but you don't want to capture the contents of a matching group? And the simple solution here is the non-capturing group operation. Like it looks like this. We have the opening bracket, we have the question mark and the colon. Okay, so this is a non-capturing group. So now everything that is within this group is non-capturing, so you cannot retrieve it at a later point. So it's just less powerful, basically. And yeah, a quick example would be, so we have free.search. Now we have the non-capturing group Python or Java. Is great. And then we have some text like Python is great, Java is great. Okay, and this will just match, yeah, Python is great, because it matches Python or Java and then is great. And this Python is great obviously is a match to our regular expression. So, but now the interesting thing is that if you store this in a match object, for example, and you want to retrieve the first group, it tells you there is no group. So it was non-capturing. There was no memory overhead and so on. So most of the time you won't actually need this non-capturing group, because you would only do it if it is kind of expensive to store it and to capture the contents of the group. So and then you would just use the ignore the non-capturing group. Or even maybe to make your regular expression easier to read, so that people don't wonder, okay, will I need the contents of the group at a later point? No, probably not. So I can use the non-capturing group. So you will see it, you need to understand it, but it's not very important that you use it in practice. Okay, so these were the main parts regarding groups, but then we also have an important topic, which is the look ahead. So the concept of a look ahead is a very powerful one, and one that any Python coder should know, basically. So a friend recently told me that he had written a complicated regular expression that ignores the order of occurrences of two words in a given text. So he wanted to search for two words. So he wanted the text to match it if there are two words in the text, two specific words, but he didn't care about the order. And so this ignoring the order is a challenging problem, and without the concept of the look ahead, the resulting code would be complicated and hard to understand. But with the concept of look ahead, this problem becomes very easy, as you will see in a moment. Yeah, but first things first. So how does a look ahead assertion work? So what is look ahead? In normal expression processing, the regular expression is matched from left to right. So let's have an example here. So okay, here I've prepared an example. So normally, so you match from left to right, and yeah, the regex engine just consumes the matching substrings. So it goes from here. It starts from the first character, then it tries to match hello world, and now you can already see the look ahead here. And at this point, it has already like matched HELLO, so indicated. So I've striked it through. Okay, so the word hello is already partially matched. And now at this point, so now it's the regex engine is at this point. It has already matched parts of the text. So this is a string, and this is the regex pattern. It has already matched parts of the regex pattern, and it is at this position in the string. And now the look ahead, basically, it just checks at this position without consuming and matching anything further. It just goes into the future. It checks at this position whether the contents of our lookahead expression, which starts with the question mark and the equal symbol, so whether this is the future basically at this position. So the substring that follows, is it an empty space followed by the character's world? And in fact, this is in fact true. So we have the empty space, we have world. So this positive look ahead would be a valid match, but it would not actually match the word. So it's a non-consuming regular expression. So therefore it just stays at this position and it looks into the future and it sees that the future looks good. So it will just return, okay, we have the match, and the match is now just the word hello. So it basically checks whether this word hello appears in a certain context. And then at the same time we have the another regex engine, say, which want to match this regular expression. So we have hello followed by the look ahead universe, and now this same regular expression, it would land at the same position, and here it would check, okay, is the future, so in the future, can we match like an empty string in universe? And it checks, okay, empty string is possible, but universe it's not possible anymore, so therefore it would return false or 0. Okay, so and this is like the overall idea of the look ahead, the positive look ahead. So you can think of it as a non-consuming pattern match. And the regex engine, yeah, it searches for the pattern and it checks whether the contents given in and as a positive look ahead will actually occur here. And now I promised you to show you how we can have this back of words check where we don't care about the order. And basically it's very simple. So our pattern is, we have the look ahead, so we just look ahead without consuming anything. So our regular expression will not consume anything, it will just look ahead. So we are now at this, so if our pattern is searched later in our, so if our pattern is searched in a given string, then it starts with the first character at this given string, and it starts at the first position 0. And here at position 0, it will just look ahead already. It will try to match an arbitrary number of characters, except new line characters, followed by the string high. Done. If this is true, now at this point it would have already matched. It would have matched the empty string. So the first position is a valid match already. If somewhere in the text in the future it sees the characters high. And now it can do the same for characters u. So we have an arbitrary number of characters coming, again, characters u, and we close our look ahead, our positive look ahead. Okay, and you can see that this is not like it ignores the order. So there's no, I mean, this positive look ahead comes after the first one, but still, as there is no consumption, in the whole duration, as the pattern is matched, the regular expression just stands at the first position and in the regular expression. So here it will, from the first position onward, it will check whether the word high appears anywhere. And then still from the first position, it will check whether the word u appears anywhere in the string. And it won't care about the order. So even if u occurs before high, it will return a valid match. Okay, so and you can see this in the following example. So we have refined all our given pattern with the string hi, how are you, yo, for example, yeah. So we don't have you, we only have hi. So this is basically an empty match. Why? Because we cannot match both look aheads, both positive look aheads. So in the pattern hi, how are you basically works. Yeah, it matches. So now there's a valid result, which is the empty string. Why the empty string? Yeah, because the look ahead, the positive look ahead, is non-consuming. So it doesn't consume anything. It just checks whether this holds, but it doesn't consume anything, any pattern. And then you can also see that we have, if you have the string where we first have you, and then we have high, then still it works. So it doesn't care about the order. So this very simple pattern with 2 lookaheads solves the problem already, like ignores the order of some matching operations. Good, okay, so this is, I just wanted to tell you, and then of course there's also a negative lookahead if there's the positive lookahead. What is a negative lookahead? It just checks whether a certain pattern does not occur in the future. Okay, so say we have this pattern, negative lookahead, so we have question mark, exclamation mark indicating the negative lookahead, and then we have the pattern arbitrary number of characters followed by high, followed by arbitrary number of characters. So if somewhere in the future in the same line we have the substring high, then it would consider it not a valid match. So then we have the text high, say high, question mark. So now what happens here? You can think about this for a moment. So basically now it starts with position 0. It sees at position 0, okay, in the future we have the string high. So position 0 is not a match. So therefore it goes back, it backtracks, we say, and moves on to the position 1. And now it checks, do we have in the future, do we have the word high in the future? So we have an arbitrary number of characters, then we have the word high, then we have an arbitrary number of characters. So in this case, the word high occurs, but we have a negative lookahead, so we don't want the word high to occur, so therefore it would just backtrack. It would tell us, okay, no, it's not a valid match, and it would move on to the next position. And then it checks for here, okay, we still have high as in the future, so it goes back, and it moves on until here. It sees, okay, here still we have high in the future, so therefore this position is still not a valid one. But now it reaches this point, and now it goes into the future. It has a negative look ahead. Is the word high in the futures? No, it isn't. So therefore this position would actually match the string. So therefore this is position 8 in our string. This matches the regular expression. You can see position 8 matches, the empty string matches the this regular expression. Good, okay, and then one final small thing is the groups flags. So you may know about flags. Say we have the find all function, we have a like uppercase or capitalized word Python, then we have text like lowercase text, Python is great. And now we say we want to ignore the capitalization, then we can just switch on the flags, re.ignore case, and you see that it still matches the text. So even if our pattern is uppercase, if we don't do this, if we don't specify the flags argument, then it won't match. Okay, you see it won't match. So therefore it allows us, the flags argument allows us to match only if our given conditions are true. So we can specify the matching behavior or customize the matching behavior of the regex engine. And basically, there's a group operator that allows us to do this in the regular expression itself. So if you are too lazy to type in this flags argument or so, or you would just want to do it within the regular expression itself, it's possible. You can do it by typing in like find all, just use this notation. So you have opening bracket, you have question mark, then you have the I flag. And here you can do any flag you want. Yeah, you can use the ignore case, you can the verbose case flag, and so on. So there are different flags. You can just Google them quickly. Probably if you are not satisfied with the default behavior of the regular expression engine, if you are doing some advanced stuff, then you can check it out. Okay, but here like this, you can simply use this simple flag. So you have the question mark and I closing operator, and then you can type in Python as you would like, and this just means ignore the case for my regular expression. So ignore upper or lower case. Python is great. And now this suddenly works. Okay, so this is the same as the previous command with one difference, which is just to switch on this flag of ignoring the case. Okay, so that's it. So you have learned about matching groups to structure the regular expression and capture parts of the matching result. You can retrieve the captured groups with the \number syntax within the pattern itself, and you can use the m.group I syntax in the Python code at a later stage to retrieve the ith contents of the capturing group, the contents of the ith capturing group. And yeah, thanks for listening to this tutorial, and see you in the next video. Bye.